All right, the rest of the lesson here, we're going to get into our textbook, so make sure you have yours out, or at least a notebook so you can write down some ideas, some notes. Okay, we are going to be talking about perimeter and area of similar figures. This is the video over here that you just watched. And we are going to jump into some problems and see if we can apply what we already know about perimeter and area. All right, so here is kind of the book, the textbook way of describing how a scale factor affects the perimeter and then how a scale factor affects the area of figures. All right, if we look here and are going to jump from that shape to that shape, okay, then we know that if figure B is similar to figure A, so like figure A is your starting spot, similar B is your ending spot, pre-image and image, then the perimeter of B is equal to the perimeter of A times the scale factor, which is what we found in our idea over here. Okay, the perimeter, you just multiply the perimeter of the original, shape A, by the regular old scale factor, shape B, and the regular old scale factor, and you get the perimeter of shape B. All right, so that's all this is saying. Down here, we notice that if you take the original shape and multiply it by the scale factor squared, or the scale factor times the scale factor again, then you get the area of the new shape. All right? So remember that sometimes we talk about the scale factor with this letter K. All right? So the perimeters are related by the scale factor K. All right? So you just multiply the old perimeter by K and you get the new perimeter. How about the areas? Well, you just multiply the old area by the scale factor twice, okay? So scale factor squared, and you get the new area. All right, so let's look at example 1. Okay, two rectangles are similar. One has length of 6 inches and a perimeter of 24. The other has length of 7 inches. What is the perimeter of this rectangle? All right, one little clue here is that when we do this, we're going to want to realize, okay, how are we going to find the actual scale factor? All right, and this is a note that you want to write somewhere, maybe in the side of your on the side on these lines over here. This could be kind of like your note-taking area. All right, I'm going to write it over here on my phone that I have linked up to the computer because it allows me to write on something other than the trackpad. Okay, so step 1, right, to find the scale factor, all right, we're just going to put the new length over the original length. Okay, so that's how we find the scale factor. And it's not always the bigger over the smaller over the bigger. I've said that in previous things just to keep things consistent, but you're always going to do the new length over the original length to get the scale factor. All right, and that's going to be a big step in this. Now, it doesn't really tell you what the original, the new, or the old, new or original shape was in this case. So we're always just going to say that the new length, or like the image length, the one that we're trying to get to, is going to be the one with the unknown. All right, one with the unknown. Okay, so in this case over here, we are looking at, okay, one has a length of 6 inches and a perimeter of 24 inches. So that has your two pieces of information. You know a length and you know a perimeter. The second rectangle they talk about has, you know that it has a length of 7 inches, but then it asks, what is the perimeter of this? So since there's an unknown there in that rectangle, that's going to be our new length, okay? The length in the new shape, okay? So we're going to put that piece, the piece of the rectangle that has the unknown on top, and the one that we do know on the bottom. And that's how we're going to find our scale factor, okay? It might help to draw a quick picture of, a length of 6, and then have a little bit bigger one with a length of 7. All right, and then we can get our perimeter. I should have drawn this on the other side of 24, and then a perimeter of, I don't know. Okay, so because this one has the unknown, that's going to be your new shape, which is going to go on top of the ratio to figure out what our scale factor is. All right, so that's a big key right there, and that's going to be a big key. All right, and then we'll go to step 2. All right, so we find the scale factor. So we find the corresponding side lengths, 6 and 7, and we put the new side length on top. So see how they put 7/6? All right, 7/6. So then now that we have the scale factor, we're just going to multiply that by the original perimeter. Right here, the perimeter of the original shape is 24. We multiply that by the scale factor, and we get the new perimeter right there of 28. All right, so your first step is to find the scale factor. Step 2 is to multiply perimeter by the scale factor that we found in step 1. All right, so that's what we're going to do with the perimeter. All right, so let's look at this. Got it here. All right, I said all right like 700 times, so I'm sorry. I'm going to try to stop saying all right. Oh, it's hard. I wanted to say it right there after I said stop saying all right. I wanted to say all right. Well, let's go with this. Got it. Triangle LMN is similar to triangle PQR if the perimeter of triangle LMN is 64. What is the perimeter of triangle PQR? So if we fill in the information here, we know that the perimeter for this is 64. All right, they gave us that info. They don't give us the info for PQR. So there's our unknown. So that's going to be our shape. Sorry, that's supposed to be a question mark there. We don't know. Question mark. There we go. That's a beautiful question mark. All right, so when we put this into our fraction, our ratio to figure out the scale factor, right? If we're trying to figure out the scale factor here, we're going to do 18 over 24, or are we going to do 24 over 18? Which one do you think it is? All right, well, in the previous one, if we look back up top here, we see that we wanted the new length to be over top of the original length, and the new length, we are just defining it for our purposes here as the one with the unknown. So if we look over and we see this guy here is the one with the unknown, so we're just going to call him the new figure. We would see that it should be the 18 over the 24. 18 over the 24. So we got that. So our scale factor here is 18 over 24. That simplifies, though. We can divide that by 6 on top and bottom. So 18 divided by 6 would be 3, and 24 divided by 6 would be 4. So our scale factor is 3/4. Once we get that scale factor, what do? Step 2 says multiply the perimeter by the scale factor. So we should say the original perimeter by the scale factor. So step 1 is to find the scale factor. Step 2 is to take that original perimeter of the starting shape, which is 64, and multiply it by the scale factor, which is going to be 3/4. And let's see. Well, we can cross simplify. 64 divided by 4 goes in 16 times. And now we can multiply 16 times 3 and we get 48. And we always measure perimeter and just length, which is one. Perimeter is a length, so it's just one dimensional. So it's not like meters squared or something. It's just going to be straight meters. All right. Hopefully you're good to go with finding the scale factor and then using the scale factor to find the missing perimeter. All right, now we're gonna go to see how, let's see. I'm going to skip over this one for now, and we're gonna get to area here. All right, area. So not quite the same as perimeter, but some similar steps. You're gonna have to find out the scale factor and then use that scale factor to find the new area. All right. So let's look this over. The Eddingtons have a 5-foot by 8-foot porch on the front of their house. They're building a similar porch. That word there. So all the corresponding angles are equal, are congruent, and corresponding side lengths are proportional. Porch on the back with double the dimensions. Ooh, they gave us the scale factor here. They gave us the scale factor. So you see they wrote down the scale factors too. Find the area of the back porch. All right, so I'm guessing, oh, here's the driveway here. So this is the front of the house. I would have thought it would have been flipped and this would be the front of the house. Just my brain says that should be it. But it looks like this is the front of the house over here. And we have a little porch here that is 8 by 5. Okay, well, I would probably do it a little differently. I'd say, well, then that's easy. It'd be 10 by 16, right? If it's doubled, all the side lengths, 5 times 2 is 10, 8 times 2 is 16, and then find the area, length times width, 16 times 10, 160. Done. Well, okay, in this lesson, they want you to use this idea that the area is always just multiplied by the scale factor squared. So we have to use this idea in this case. So we find the area. We're going to find the area first. We're going to find the area of that front porch first, which length times width is 8 times 5 gives you 40. All right, so you have a area of 40. So since we already have the scale factor here, okay, we don't have to find that. Sometimes you will, but then we just take the original area and multiply it by the scale factor squared. And that was in our original notes over there at the beginning on page 570. There's that little box. That's the key concept. But the idea is that you take the original area, you multiply it by the scale factor squared, and you get the new area. All right, so that's one of our key concepts. I think they flipped it around and said the new area equals the original area times the scale factor squared, but I like it this way. All right, so in this case, we had the original area of 40 times, what was the scale factor? 2, and then we square that, and we get our new area. So we had 40 times 4. Remember, if we're doing PEMDAS, we would, or GEMS, or order of operations, we do the exponents before we do the multiplication here. So we're going to do 2 times 2 is 4, and then we get 4 times 40 is 160. And in this case, we're going to have square units because it's a 2-dimensional measurement of area. So that's going to be square feet or feet squared. Okay, let's look and see how we're doing if we get an example here to try. All right, Malia is painting a mural on her bedroom wall. The image she is producing is 4.8 inches by 7.2 inches. If the dimensions of the mural are 10 times the dimensions of the image, find the area of the mural. All right, well, like I wouldn't normally do it, I'm going to draw over here. It's a little easier for me. 4.8 times 7.2. Okay, we're going to do length times width to find the actual area of this guy. Okay, I'm going to need some assistance there. Oops. So let's get my calculator out. All right, we got 4.8 times 7.2, 34.56. All right. All right, 34.56 is my area. And that's, what do we got here? Inches, so that's in square inches or inches squared. All right, and then what are we going to do with that? Well, we're going to take that area, the area of the original, just like we set up here, area of the original times the scale factor squared gives us that new area. All right, so we're going to take the 3456, we're going to multiply it by the scale factor squared, which is 10, the scale factor is 10 squared. So we get 3456 times 10 squared would be 100. And we've worked with this before. Multiplying by 100 actually just moves the place value over 2 places. So the area is going to be 3,456 inches squared. All right, and let's see if that worked out for us when we pop on the answers here. Boom, got it. All right. Good luck with this. We'll do some practice problems, and I'll try to make some more videos about how the practice problems work in case you're struggling with any of them. All right, thanks for watching.